Atomic number. So on your periodic table, okay, remember the atomic number on the one on the wall is blue. Okay, it's the one up in the upper right hand corner. On the periodic table that I gave you the other day, okay, this one, it is the upper left hand corner. So it really just depends on the periodic table. But you should be able to pick it out because it's not going to be the number that is a decimal. So the atomic number of oxygen is what?
8.
8.
Why did my voice sound so
Okay. Now, the number of electrons in each energy level. How many electrons are in the first energy level of oxygen? The first energy level. 2. Okay. Oops. Oh, I messed that up.
Yeah, you did.
So I'm just going to put 2 electrons in the first energy level. How many go in the second?
6.
There are 6.
Wait, what you write next to the E? Is
That's, I messed up.
What is that?
That's a
Oh,
scribble.
that's a negative.
It's 2E negative.
2E negative? What
Okay.
does that mean?
2 electrons.
Electrons are negative.
Remember, that's the symbol for electron.
Are electrons negative?
Electrons are negative.
I'm so retarded.
Now, listen. If you look over there in the right-hand side, do you see those numbers up there? The black numbers on the right-hand side of the periodic table for the people that are up front where it says 2 and then 2,8 and then 2,8,8.
That's what those mean.
That's what those mean. That is the number of electrons that can fit in that energy level. So like the first energy level is 2. Second energy level is 2 and then 8. So 2 in the first, 8 in the second. Third energy level, on that row, it can fit 8. But then once you go down to the fourth row and bring in the D sublevel, it brings in 10 more. So it's 18. The fourth energy level is 8. Go to the next row. You got 2, 8, 18. The fourth energy level brings in the D sublevel. You have 18 and then 8 for the new energy level. So it tells you how many electrons can fit in each energy level there.
Makes
Yeah,
complete
Grace.
sense.
Why do they write 6?
Because
Because you're the
oxygen, Macy,
I
be nice.
know.
Look, there's 2 electrons plus 6 electrons is 8. So there's 8 total electrons
break.
in
Wait,
oxygen.
so 2 plus, is it just a coincidence or is this why? 6
Grace,
plus
you
2
want
is
me to
8?
tell you?
No,
Is there a coincidence? Is what a coincidence?
that like 6 and 2 add up to be the atomic number.
Well, you have to remember the atomic number, as long as the atom is neutral, is going to be the same as the electrons. So it's not a coincidence. Like it is what it is what it is. So, all right, now our electron configuration. We have 2 electrons in the first, so 1s2, and then 2 what? What comes after 1s2?
2S.
2s2. Remember, on your periodic table, this is your S sublevel. This is your P over here. This is the D sublevel, and this is the F. So 1s2, 2s2, 2p what?
6. No.
Not 6.
No, 4.
4, because there's only 8 electrons. So that's your electron configuration for oxygen.
Cut me a break. I haven't been here since Thursday.
Hey, you never cut me a break, Macy.
Macy, chill.
All right, now, we're going to start thinking about this, and this is going to make a little bit more sense and be a little bit more meaningful once we actually get into bonding. But the number of electrons probably lost or gained. All right, I'm going to make this easy on you. You see where oxygen's at on the periodic table? Right here. Okay? And remember, what did we say earlier? Every atom wants to have 8 valence electrons. Well, how many does oxygen have now? It has 6. Because look, you got the 2 and the 2s, you got the 4 and the 2p. So that's a total of 6. How many does oxygen, do you understand that?
No.
Look, your outer energy level is the second energy level. And you got 2 in the 2s, and you got 4 in the 2p. So that's a total of 6 in the second energy level. Does that make sense?
So you
Always the outer. Yeah. Honestly, when we're talking about bonding, the only thing that matters is the outer energy level electrons, the valence. Okay. So, think about this. Oxygen's right here. To get 8, it has to do one of two things. It either has to gain 2 or it has to lose 6 to empty out the outer energy level. What do you think is easier? Gain 2 or lose 6? It's easier to gain 2. So oxygen's going to gain 2. So number of electrons left after the loss or gain, okay? So this is how many electrons you have after it has gained 2. So if you had 8, you gained 2, what do you have now? 10. All right?
Really, it's 6.
Yeah.
We have 6 in the outer energy level. We have 10 total,
8.
okay? Now, think about this. How many protons does oxygen have? It has 8. How many electrons does it have? It has 10 now. If it gains 2.
I'm sorry.
Okay? Look.
Can you just do one more after this one?
Yeah, I will.
That look was
Thanks,
funny.
Mr. Harrington.
That was
Thanks.
like pasty.
So, if it starts with 8, gains 2, it'll end up with 10. It has 8 protons. Therefore, it's going to have a charge of -2. Okay? -2. Now, you have to think of it like this. If it has an even number of protons and neutrons, or protons and electrons, sorry, it's going to be neutral. So it's going to have a overall charge of 0. If it gains electrons, it has a negative charge. If it loses electrons, it has a positive charge. Not because it gained protons, but because the number of electrons is now less than the number of protons. All right, let's do another one here. So sodium, on your periodic table, Na, right here, its atomic number is 11. Now, the number of electrons in each energy level. Now, sodium's in the 3rd row, so that means it has 3 energy levels.
So 2,
It's got 2 electrons in the first.
Where do you get 2 from?
and then 8.
All right, Jimmy,
1, 2, 3.
there can fit 2 electrons in the first energy level. So if it has more than 2, it's going to be 2 electrons in the first energy level.
Then 8.
And sodium has 11, so it's always going to be 2 in the first energy level. Then
8
8 in the second,
and 1.
and then 1 in the third.
I get this just now.
Okay. So that's a total of 11. All right, so the electron configuration is 1s2, 2s2, 2p6, 3s1. Whoops, 1. Sorry. Put a 2 there.
That's cute.
All right, 3s1. So that's your configuration for sodium. Now look at where sodium's at. Sodium's right here, group 1. You think sodium's going to gain 7
No. He'll lose 1.
or lose 1? It's going to lose 1. So when it loses 1, the number of electrons is going to be
I just felt lose
10.
Wait, so the goal is to get to 10 electrons?
No, the goal is to get the same number of electrons as a noble gas. It just so happens that oxygen is going to be like neon. Sodium is also going to be like neon. So they end up with 10, but that just happens to be a coincidence. All right. What's the charge on the ion? Positive 1 or negative 1? Positive 1. Because if it loses an electron, it's going to get positive because it now has 1 more proton than electron.
So if it loses, it's going to be positive. If it gains, it's going to be negative.
Yes.
That makes no sense. Okay.
Okay, it's all because, think about this. If you lose negative things, that's a positive. If you gain negative things, that's a negative.
Okay.
Does that make sense?
Like, if you won $1,000 in taxes, would you be losing or gaining money?
Losing.
That's what he's trying to say.
Yeah, that just
Maybe.
made me. Yeah, Jimmy, that made me so. Yeah, that was so much.
That
more
was
confusing.
confusing.
Oh, just
All right.
talking.
Let's look. Hey, let's just look at a couple more examples here. So, sulfur is the next one.
Can we like do it and then check with you?
Yeah.
Let's do one more,
Okay.
and then I'll let you do that.
Let's do that.
Okay. So sulfur right here, and sulfur. What's its atomic number?
16.
16. And number of electrons in each energy level. So how many are in the first?
2,
2.
8,
How many are in the second? 8.
Smart man.
How many are in the third?
2. No.
6.
6. Okay. 2, 8, 6. Look, Jimmy. It's the 6th row or 6th column over. 1, 2, 3, 4, 5, 6.
Why do you skip all the ones in the middle?
Well, for one thing, there's nothing here.
No, for like the next row.
Well, the reason why you do that is because this is the 4s, this is the 4p, this is the 3d. So I'm not concerned about the inner electrons. I'm only concerned about the ones that are in the outer energy level. So the 4th energy level, which is made up of the s and the p here, that's going to make up your outer. So that's why you skip over those d sublevel electrons. All right. Electron configuration, you got 1s2, 2s2, 2p6, 3s what? 2, 3p4. Okay?
Wait, hold on.
Now, for sulfur, right here, okay? It's in group 6. What do you think is going to happen? Is it going to gain 2
Gain
or
2.
lose 6?
I know that.
Gain 2.
It's going to gain 2. So gains 2. Now, when it gains 2, how many electrons does that leave it with?
16,
18.
just kidding, I lied.
All right. And what is the charge on that ion going to be?
Negative.
-2. All right. I'm going to go ahead and let you do